Okay, my friends, I came to a realization that there is so little understanding of science. And I'm going to tell you right now, I'm confronting you. Yes, if you think you're a science person, I want to hear from you. I put this up. Who can explain fire? Nobody could explain it. Who can explain heat? Who can explain cold? Who can explain any of this stuff? Nobody could explain it. Now, and I understand why they can't explain it, because they're trying to use the current Bohr model, which now has been proven it's wrong. And the only reason they admitted it was wrong is because of the work that Rod Warren and I did with light. Say what you will, that's the only reason they admitted it. 5 years they knew about it until I started flooding the airwaves with these pictures that absolutely, certainly show what I am saying, and I will prove to you that I am correct, uno momento. But I want you to know that 50 years ago, I was doing these experiments that turned heat into electricity. They don't even understand this today. I mean, they do, then they don't. But here's what I mean, I did the actual experiments. The heat of calorimeter, I took the heat of neutralization and solution, heat of reaction, all of these different calculations and how the temperatures changed and all of that stuff. This goes back 50 years. Now, and then how everything mixed and all that. And then I got into how all the heat transferred into electricity. And you end up getting into electricity. You understand? Nobody understands this. Heat is electricity. That's all it is. I gotta be honest with you, I really can't remember a lot of this, well, 99% of it, but I did remember that it ended up power dissipation is watts, really. That's the amount of watts. Now, when it dissipates in a certain amount of time, it's transferring the electrical energy. Now, what is the electrical energy? That's what it boils down to. What does electrical energy mean? What is it? Okay, what she's going to be talking about is exactly what I discovered is the dark matter particle called the muon, and the electron neutrino I also discovered in some research. Well, it was really just experimenting, playing around, really, Rod Warren was doing. And he was posting these pictures online. I'm thinking, wow, I realized what it was, and I got a hold of him, and he worked with me for a couple of years doing the things I asked him to do with the lasers, and then I could see all the particles. I know exactly what's going on here, no question whatsoever in my mind. And if you have a different opinion, I want to hear it, and I want to hear why. Now listen to what she's saying, and the only reason she's saying is because of what I posted online. Now this is the Royal Institute. They have 902,000 geeks watching this, and this is the standard model wrong? Absolutely it's wrong. Here's what she's going to say. I'm going to cut right to the chase. Here goes.
Why this is so interesting and thrilling is that, besides being unexpected, this could genuinely be the first sight of something new. Because if, when we've analysed more data, this difference between muons and electrons stays, and lepton universality seems to be violent.
Let me just explain something. The difference between electrons and muons, and we can see them actually separate. Before, there was no reason to suspect that there was two different sets of materials, one of them being dark matter and one of them being energy. Now there is every reason to expect that. Now let's go back again. Just listen to what she said.
That besides being unexpected, this could genuinely be the first sight of something new. Because if, when we've analysed more data, this difference between muons and electrons...
All right, this difference between muons and electrons. Wait till I show you that we can tell you that there's 100% certainty that there is likely a difference.
...stays, and lepton universality seems to be violated. Well, what that means is that there's something wrong with the standard model. We found the crack, finally, in our understanding of particle physics. There's absolutely no way that we can explain this observation with
And the observation is what I will show you in a second.
Our current understanding. In fact, the only way we think we can explain what's going on is if there are new particles in the universe associated with new physics processes beyond those that we understand, and that these new particles are interfering with the B mesons as they decay and suppressing the decay to muons compared to electrons. Now, if that turns out to be the case, that will truly be momentous. Forget the Higgs. This will be the first sign of physics beyond the standard model, and it's what we've built the LHC to find out.
Well, we didn't need an LHC. We used a very simple Venturi. And we started with light. So we started with literally almost the smallest particles there is. There's only one smaller particle, and that is the electron, and then the smallest, the electron can actually split. I will show you in 2 seconds here exactly what I can prove dark matter and electrons, muons and electrons can separate. I'm going to show you in a second. There's the red laser. Pip, 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 pip. Accelerates because we use the Venturi. A Venturi makes particles accelerate. Light are particles. They accelerate and concuss, and the dark matter separates and completely surrounds the white matter, which is the concussive electron. So you have a muon and you have an electron. One of them has no energy whatsoever, none, zero. The only thing it does is attract, and it wants to be with the white one. When they concuss, it wants to be out of the action. Now, here's my proof. You see this? Now they're claiming that they figured it out because of nuclear decay breaks standard model. And they're saying electron positron decaying from beryllium helium hint at a new boson. Well, I don't have to hint at anything. I'm going to show you mine. And they claim that this has been going on for 5 years. Look, they know this since first experiment results back in 2015. And the publication is 2016. They've avoided it because nobody's ever really seen it. This has only been expected that there was more dark matter than there is regular energy. And now I will show you why we can say that pretty certainly. All right, this is what they built the LHC to try to determine if they could find electron showers, which are just huge round circular disks of energy, which cascade like billiard balls away from the particle that initiates that shower, electron shower, and there's the muon, which is the attached particle to this that has no energy at all. It just rolls away. That's the black particle, and that is dark energy and dark matter, and they call it a muon. I don't care what you call it. It has no energy. It fulfills every requirement they say for dark matter. No energy to speak of. It's attractive and creates gravity, yes. Absolutely, no question whatsoever. However, it can completely separate from the energetic part of the electron, and it doesn't absorb, it doesn't emit, and it doesn't really do anything other than get out of the way of the interaction of the electron showers, and I will show you that right this instant. All right, just so you do understand, nothing I am saying here is accepted by anybody other than me. This electron flood theory is my theory, and I can see it, and I can tell you right now, when that particle came in, it looked like this. It was back-to-back black and white particles, and when it concussed at the Venturi, these black particles walked away. That is the muons. This is the electron shower, obviously. The muons come back over here, so they can completely separate. 100%, no question whatsoever, the muons can separate from the electrons. Just exactly what I showed you a second ago, what the LHC is looking for. Here it is. And if they can separate, there's no reason to expect that they can be a difference. They're not universal. In other words, they're not exactly equal. There could be more dark energy, and I believe there is, because that is the gravity. Now, I think I might have showed you this before, but this is just a very simple red laser, nothing like CERN's doing. But we started with light. It's accelerated, but then when you put it into a Venturi, a laser, it concentrates it. When you put it into a Venturi, it has to accelerate. I showed you the separation of the black particles from the white due to the acceleration and the energy, which that energy, the only reason it's becoming totally energetic here is because you have the particle, which I will show you in a second. It's this particle right here. All right, that's the particle. that enters the Venturi. When it does, all this breaks to bits. The white balls explode like a bomb. The black ones just roll away, as I showed you just a second ago. Now, the reason for that explosion is it's not just this little particle. There's a region around it. So like huge, huge, huge region. And when it gets into that Venturi, all of that stuff's got, that region itself has to compress. And it pushes into everybody else's regions. If you push a region of an electron's influence into another electron's region, it will heat it up. It just does it. I cannot explain the interaction there. But the harder you push, the more it will heat up. If you force, and in my electron flood theory, all there is electrons. If you keep pushing more and more of these electrons into some particle or matter like this, you force electrons into this, it will accept them and it will get warm. And then when they bleed back out into something else that wants to take them, that it's colder, it wants to accept electrons, they bleed over to there. That's what heat and energy is the movement and the pressure of electrons against electrons. That's all heat and energy is. They own huge regions, little particles. And when they're in space, they still own huge regions, but the little particles so small, you see right through all that stuff. So there's nothing out in space. At 100% certainty, these particles are coming to us from the sun. And they will come in this configuration, and they will come in this configuration, which is an electron. So if it's an electron, it's extremely energetic, and it wants to be either attached to another electron to make a photon, and then it becomes basically neutral. And when it hits you, it bounces off. Depending upon how hard it's going, what it's made, they're electrons, how hard it's going and what it's hitting determines the color you see and the brightness and all that business, and a number of them hitting at the same time. There's a lot of little nuance, but it's nothing that's that hard to figure out. Much, much simpler than what they have now. I'm going to tell you that right now. And the simpler it gets, the more likely it is to be correct. And my simplicity here, I have always been one of the most simple people. You can ask anybody. Yeah, Roger, he's a simpleton. Now, here's what's coming. There's the light from the red laser. Now, that is not simply what you're seeing there. That's not the entirety of the light. The entirety of the light is like this. You don't see this. All you can see, and we will see, is that little bitty particle that's in the center. Now, it's coming through, and as it does, it's forcing all of the stuff in front of it to get the hell out of the way, which excites it. All these are excited particles. That's why they're excited. Now, they're excited in a frequency that this is tuned to, the red laser. It's the red frequency. Now, so there it comes out, and it would just keep going like that unless we put a Venturi, which is nothing more than like something that went like that and something that goes like this. And the light's got to get into that and crush itself. Don't forget, they're big balls like this, and there's a ton of them. You see, they're all over the place here. You don't see them because this is the only one where you're seeing is accelerated. But light is everywhere flowing through the air. The only reason these are so bright is because this is the pushback. If you could see that, you see this, that's the pushback from the concussion. It's absolutely stunning how devastating that concussion is. Now don't forget, all the black ones are out here. Here's the white ones right here. That's this. We're looking at the electron showers. That's exactly what CERN wants. That's what they built that LHC to do. They should have called us. We could have helped them. Plus, we would like to know what that particle is, CERN. Maybe you have an idea. That appears to be a reverse spinner because it came through the accelerator in a different manner than all the rest of them. And I can show you that, and I guess I will in a second. That's the particle. This shows you that it's spinning to the right, which means it's drifting to the left as we pulse it. and it's separated, it's concussing. That means light is expanded and slowing down. Okay, that's that little reverse spinning particle, and that hit and gave us a very strange particle. I'm going to show you in a second. But I want to just make my statements here. This is what electron flood theory says. All electrons have a concussive and a dark energy. That, as far as I'm concerned, that's dark matter. Call it a muon, call it a whatever you want. Now, and they are attached together, and in every proton, there's 1,837 of these dipoles. That makes it a charged particle. 1838 is a neutron. It's neutral. Now, the reason they form in these quantities is because the whole universe has a hum, and I believe it's 432 hertz, somewhere in that range, and that hum makes these quantities of polar molecules shake until they become stable, right in this range, and it goes up one at a time. And that's why they've always thought they were just one big particle, one big proton. I'm going to show you. And then photons are what normally electrons do when they're going as a source of light. They're attached together. Electrons do flow through the air, but they flow through as lightning, static, and true electricity, which is extremely invasive. Photons bounce off of you. What you're seeing when you see light, and you see all this right here, there's different molecules in these different colors, and they have different impact values, like a balloon being real hard and a balloon being real soft. You bang into that balloon being real hard, and it's going to bounce back real hard. You bang into the soft one, it's going to bloop and bounce off like that. That's what you have here, and depending upon how hard it bounces back at you, it's blue, green, red, down, and then all the different colors in between. Because as you add all different molecules together, you get different colors. And they can, you get the rainbow. Let's just go with that. All right, so here's what electron flood theory is. Now, let me just give you the extreme details. This is all you need to know. I'm serious. This is it. And your case is closed. You are a physicist. This was the old theory, and it was wrong, absolutely wrong. And it never did work, because you couldn't have one gigantic positive chunk and one little tiny negative piece out here floating around, and they wouldn't go together. It snapped together. It was just totally wrong. So that was, and this is really current theory now. They think still there's one big thing in the middle. They really have no clue right now. They're still, they're like when she says, oh, the mesons are working on a decay. No, there's just nothing more than electrons. So let's just X that out. Now, here is my theory, electron flood theory. This is the new correct theory. Now, every nucleus will be surrounded by electrons, all right, which is the explosive part of these particles. And they will force the negatives, or the positive, non-reactive part into the center, because they don't mind being around each other. They'll touch. These guys want to be out. Get away from me. Get away, get away. So they were going to go as far away as they can. They want to be attached to a dark matter. That's the nature of particles. They want to be in this configuration here as electrons. All right, can you see all this? No, you cannot. Here we go. I hope we saw the other part. Let's just go back to it. The old wrong theory is what we're looking at right now, is one gigantic proton and one tiny electron. Doesn't work. There's 18 in the smallest there is, which is the nucleus of a hydrogen atom, and that's the tiniest hydrogen. This is hydrogen 1, 2, and 3. It's not just one hydrogen. And it's 1,837 electrons in the core, and then it has the potential to influence one electron in its surrounding region, because that electron wants to get to the core, But this says, no, 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 we got enough electrons, we're going to push you away. And it stays in an exact distance depending upon how many exact electrons are in here. So if you have 1837, and that's the exact number you're supposed to have for an exactly stable hydrogen 1, and you have, instead of 1837, you have 1850, it's going to be pushing that harder away. If you have 1835, it's not going to be pushing it as hard. It's going to be closer. There's a whole lot of variation in these atoms. They're not just locked into one, this is a this, and this is a this, and this is a that. Absolutely not. In between every one of these, there's thousands, literally thousands of particles that can occur in between every single one, because there's thousands of electrons, because there's thousands in every proton. 1837 electrons make a proton. That's all there is one proton inside of a hydrogen atom, the smallest hydrogen. And then you have all kind of isotopes. They never can account for any of this stuff, because if all you've got is one gigantic proton, well, how are you getting all these isotopes? They were so lost. And now they agree, well, the nucleus is made out of quarks. Well, quarks are electrons. By the time you get down to the bottom line, you got an electron which has this, a dark matter portion, which is your positive, and you have a negative, which we've always thought was the only thing there was in an electron. Well, it's not the only thing. It has the dark matter energy attached to it. It's just as simple as that. This one explodes. That one never did anything. We never saw it before. The only reason you saw it is because of Rod's pictures. That's the only reason. And it's electricity, static, lightning, interactive, and it damages this electron here. Now, photons, a little bit different. There's two back-to-back electrons, bloop, bloop, just like bar magnets. Either a bar magnet this way and this way, or that way and that way, either way, however you look at it. And it's basically neutral. It will not invade you. It will bounce off of you. It may heat the hell out of you if it's strong enough. And it's intense enough. Like lasers, they'll burn through things because there's just so many of them hitting at the same time. It's a little different than any natural sunlight. All right? The most extreme sunlight there is will not do what a laser will. No. The colors are the bounce frequency of the matter that it hits. A soft, spongy thing it hits, you're going to see a certain bounce back. A real hard thing it hits, you're going to see a different bounce back. It's just basically as simple as that. And they call it string theory. Well, it was nothing more than like strings around a nucleus, and the closer you got, it was the tighter the string, which would make it bounce faster. And the further out was the gushier the spring, and that would give you the red light. If it's got all the way down to the blue string down the inside, boing, she's going to take off like a rocket ship. Now, that's it. That's all you have to know. That's now. Every interaction that you see, everyone, think of what would happen with your electron moving in and out of that reaction. And as I say, heat and cold is nothing more than electrons, excess electrons, and you have them there everywhere. Everything here is filled with excess electrons. Zillions of them. And if you walk through the air on a cold, dry day, you will get loaded with them because they're everywhere. They want to be attached to water molecules. You got a little water in you, and it says, oh, go on, Roger. And they attach to me. And then I go to the sink and I touch the faucet and boom, they go into the earth, because the earth is a spinning magnetic attractor of electrons. It goes from the South Pole up to the North Pole. They suck them to the earth. The electrons are being sucked to the earth. Hydrogen does not have enough electrons to be sucked to the earth. It goes away from the earth because it's just one of the few things that there is that doesn't have enough electrons to come down to the earth. Now, you say that doesn't make sense. Well, here's the deal. Because hydrogen is so small in this core mass, it can only influence a very small particle, and that particle is going to be at a very long distance away. Hydrogen has a 21 centimeter line. Look it up. 21 centimeters is the region that it influences magnetically. So what does that tell me? That tells me that that particle has 1,837 electrons. However, its electron that it controls is so far away that its region is so huge that it doesn't have enough mass in that region to come to the Earth. It goes up. That's the only reason it goes up, because it influences such a huge region around itself, but weakly. So it just drifts up in the air. It doesn't have enough electrons in the region that it controls to go to the Earth. And the more electrons that are in the region, the harder it comes down. You get lithium, and then you end up with gold. Gold is like, boom, slams to the Earth. Gold, is heavier than uranium, I believe. Just a smidge heavier than uranium. You got to look at specific gravity and understand specific gravity, which is nothing more than the density of electrons within a certain mass, within a certain distance. So if you took like 1 square meter of space, the more electrons you put in there, the more specific gravity, the harder it hits Earth. Simple as that. And gold appears to have just a complete saturation of electrons. And I believe it's because the neutrality of gold is so stable that there's not a whole lot of excess unstable areas in there. Basically, that's what it boils down to. That's why gold is so heavy. It's very stable. All right, at some point I said that I would talk about this reverse spinner and what it did when it impacted with one of these particle disks. And here's exactly what it did. It gave off this, whatever that is. So think of this extremely carefully. That, in my mind, was an electron. All right, these are the things that electron showers. They have separated from the muon. So that is and that is something different. So we got a whole lot of thinking to do. Now, I believe that green is only the reason difference between green and red and blue is the speed of the spin. And what I mean by that is electrons spin. All right, that's an electron. When it's going, it's spinning like this. And the spin, if it's spinning real tight like this, it could be blue or green. And if it was spinning real slow like that, it's going to be like red. And the slower it spins, the less impact it has. So red is not as energetic as green, and blue is even more energetic, because blue is going zzz, green is going and red is going. Now, that's the key to the energy. And I believe the reason for these different spins is if it's being pulled from the nucleus, right close to the nucleus, you're going to get a blue spinner, because you're really going to have to pull that sucker out of there, zoom, and it's going to be pulled out tight, hard. If it's way out from the nucleus, say, halfway out, you're going to have to pull it, but not all that hard, and it'll come out green, and it's going to spin that speed. And if it's way out on the edge, it could drift off fairly easily in the red region. Now, that's my interpretation under electron flood theory. You see this, how cool this is? These are the red laser particles coming out, which are electrons forced through the accelerator, and now they have become just electrons, and we know the dark energy is around the edges. Now, look at this. They are all equal energy because they came through the accelerator, same particles, the same speed, same frequency. Look at this. Why is that blue? How'd that get blue? It's not supposed to be blue. It's supposed to be red. Well, look at this. You see this? And you see that? This particle appears to me to be being crushed. And like I told you before, anytime you push against a particle, it will increase its energy value. Look at what happened to it. It turned blue. That's a more energetic. It crushed it and it elongated it. And now it's slowing back down again. It's still elongated. See it? That's the particle way at the tip. These particles, you see that little tiny thing? That's the particle. Right? They have a little tiny particle in the middle, and it creates this wave of circular motion. Now, I don't take into account these little strips because I think they have a different source. This little curve here. Don't worry about that. I believe that I don't think you would see all that little stripes in these like fingerprints. They would be just circles, like grooves on a record. All right, but that one there has increased in its energetic value due to virtually another Venturi. That's the same as a Venturi. You're crushing it to force through a region that's making it compress. That's all energy is compression. An atomic bomb, they take the most heavy, dense stuff they have that is so filled with particles that there's just no extra room, and then they force it into itself, and then everything just gets so chaotic. You get this craziness coming out of here, and then you get particles and chunks. Not only do you get electrons, you end up getting half like that. Say that was a molecule. It would go like this, and gigantic pieces go flying everywhere. That's called radioactive pieces. They are not fully stabilized as particles. They will slam you, and they will try to force themselves to incorporate into you, and they will devastate you. These, at this point, they're electrons. In my world, at this point, they are electrons, fully separated from the dark matter. Now, normally, the electron and the dark matter are going to travel together. The only reason they're separated is because there's Venturi, in my mind. This is a very, very, very unusual situation. And I think this could be exploited, but I don't know. All right, I guess we can start to sum things up here. That, again, is that particle, and it is just like this. Now, that's light. It bounces off of you, and you can see it. You heat up a little bit, and you glow a little bit, but it does not kill you. This is an electron. This is half of one of the photons. And electrons will kill you if they're concentrated enough. If they're not, they will just warm up, and they will weasel their way into the material like this rock here. They will work their way in there, and it will become warm. And everywhere you go with this, it will keep that warmth until somewhere else wants to take those electrons, and they'll bleed off. That's what it is. That's what heat is these things right here, moving in and forcing their way in because there's heat pushing them in. And the stone and the rock will say, all right, I'll take some of that, come on in. And then it'll heat it up. And now everybody becomes the same temperature, no problem. There's no push to shove. All of a sudden, you turn the heat on in the room, and this is cold now compared to what's in the room. They will force their way in. You turn the heat off, open the door, and it gets cold in the room. There'll be so many of them in here, and now out here they'll say, well, we could take some of them. And they'll say, okay, go out there. This will start to lose its heat, which is the electrons. That's all it is. The only thing there is the whole universe is push to shove. That's energy, and the only thing that makes energy is electrons. And the only thing that makes energy out of electrons is push to shove. If they just sit around like this, there's no energy whatsoever. They're just sitting around doing nothing. And that's what happens in the vacuum. They call it the vacuum of space. It's not a vacuum. They're out there. They're just floating along. Now, they are really, at that point, non-energetic because there's no push to shove to anybody. Well, they do. They interact with the things around them, and they do slow down coming to us. The universe is not expanding. That's insanity. The particles are slowing down. These are particles. They're slowing down as they come to us. Hubble had to work with Einstein's theories, and we can see right now Einstein's 100% wrong. I'm sorry, Professor, Dr. Einstein, whatever you want to call yourself. These are particles. They're accelerating. They have mass, they have energy, they can slow down, they can speed up. I mean, what can I say? They can split apart, the dark and the white. So now, I am going to go with the fact that, yes, we can have more muons than electrons, and I believe that's the case because of gravity. And they, I think, now will agree in the Royal Institute. And I'd love to have them talk to me. You know, nobody seems to be interested in discussing anything with Roger. Well, let me tell you something. That right there, my friend, is above CERN. CERN is working with gigantic chunks of particles. They're working with huge nucleuses, thousands of little bits of particles, smashing them into just debris, then digging around trying to find these. Well, I got them all over the place. There they are right there. And we started with this. We didn't start with that. So we don't have to dig. They're looking through things like, you know, they've got globs of things everywhere. They have no idea what they're looking at. And then they find little tiny things. They say, ooh, look at that thing. That's very strange looking. What is that? You know what? That must be a muon. Well, yes, it is. And it was attached to an electron. And these are where the electrons are as a violent, extremely violent event occurs. This is not your average situation, I don't believe. I think it's normally just going to be that glow. But once you get this, where the black ones will not go along through there with the white ones. They're just not going to do it. And I think you can exploit this region right here. There's a region right in here where there is nothing but electron showers. Is that exploitable? Je ne sais pas.